Hi everyone, I welcome you to the presentation of this lecture on Pascal's Triangle, Engineering Mathematics. So a binomial expression is one which contains two terms connected by a plus or a minus. Therefore, P plus Q is an example of a binomial expression. A plus x squared, 2x plus y, the power 3. All these are examples of binomial expressions. So when you're expanding this binomial expression using Pascal's triangle, you're supposed to take note of this. This is a Pascal's triangle which you can easily come up with. So it starts with 1. So an expression which is a plus x. A and x, these are just terms in that expression. If it's to the power 0, then it will have a coefficient of 1. If it's to the power 1, it's going to have two coefficients, so there will be two terms. So the coefficient of the first one will be a 1, coefficient of the second one will be a 1. Just like that. For the 2, those will be the coefficients. For to the power 3, you're going to have that. So what you need to note here is on how to generate this Pascal's triangle. So it starts with a 1, and then you do ones like that. For the third one, you just be adding 1 plus 1, you have 2. Then you put ones there. Here it will be 1 plus 2, which is 3. 2 plus 1, it's a 3. Then you put ones. So it will be opening with ones like that. For numbers there, you just be doing the additions. 1 plus 3 will be a 4. 3 plus 3 is 6. 3 plus 1, 4. You have ones like that. All the way this thing can grow as much. So the expression is basically this. When you're expanding such an expression, we are having this. So C1 is basically the first coefficient. So therefore the terms which are A and X there, A will start reducing from N up to 0. So it will reduce from N, it will go all the way up to 0. And then the X will be increasing from 0 all the way up to the power of N. So you understand once we do an example. When we look at this example, expand the following. So you have this a plus x to the power 0, b 2x plus y to the power 1, c 6a plus 2x to the power 5. Let's look at the solutions. So for the first one, ax to the power 0, we are basically following this expression. So we'll start with the first coefficient. A will start reducing from n until it goes to 0. Then x will be increasing from 0 until it reaches n. But as you can see, our n there is 0. Therefore, for a plus x to the power 0, as you can see, the coefficients from the Pascal's triangle is just a 1. So where there is a coefficient there, we'll put a 1. Then a will start reducing from 0. Then x will increase from 0 like that. But since we are not going anywhere, it's just 0, and then you realize that a to the power 0 is 1, x to the power 0 is 1, therefore the expansion of this is a 1. And automatically anything to the power 0 is a 1. So we have that one. For b, we have this. So our interest is checking the Pascal's triangle. So for where n is 1, the coefficients are these 1 and 1. So you start with the first coefficient, then this first value will be to the power n. It will reduce until it reaches 0, and then this second coefficient will start from 0, it will increase until it reaches n, which is a 1. So the first coefficient there is a 1. The first coefficient there is a 1. This 2x to the power n, our n is 1, like that. Y is starting with a 0, which is that one there. Then this one here, the second coefficient is also a 1. This first term, it's now reducing from 1, becomes a 0. And this one was a 0, it will become a 1, which is that one there. Then we can easily simplify this. When you simplify, you realize that you're going to have 2x times x to the power 0. Because x to the power 0 is a 1 times 2x, you're just going to have 2x. 2x to the power 0 is a 1 times y, you're going to have a y. And that is going to be our expansion. Okay, we'll look at the last one. So for this expansion, our interest is coefficients for n is 5. So where n is 5, these are the coefficients 1, 5, 10, 10, 5, and 1. So we'll be working with these. So you get a coefficient, this term will start reducing from 5 until it reaches 0. Then the second term will start increasing from 0 until it reaches 5. So that will be the formula there. So you realize that when you get the first coefficient, which is a 1, you get this one, which is 6a to the power 5, of course. 2x you start with a 0. Then the second coefficient there is a 5, which is this one. This term, it was a 5 there, it becomes a 4 now. This term was a 0, it becomes a 1, which is this one there. You get another coefficient there, which is a 10. If you get a 10 like that, you realize that this 6a, it was a 4 there, it becomes a 3. This 2x, it was a 1, here it becomes a 2. It goes all the way. Then you get another term, which is a 5. When you get a 5, you realize that you're going to have that. And then the last one, which is a 1, which is this one. So the first term, which started with a 5, goes on up to 0, which is this one. And then the last term there, which is 2x, started from 0, it has now become a 5. And then you just start simplifying now. So when you simplify, you realize that when you do 6 to the power 5 and 8 to the power 5 times that, you're going to have this. So this is just an expansion. Expand this to give you that, expand that to give you that, and this is going to be your final expansion for that expression. So using Pascal's triangle, you can expand any binomial expression. The next presentation, I'll make a presentation on binomial expression using the formula, the theorem, binomial theorem. Thanks for watching.